Okay?
Good for you. You want a cookie?
Maybe. Now.
He's been doing that all year, Miss Seaman, so.
He's been doing what? Being better than me?
Saying.
Oh!
I never said
Saying that he's better than me?
Have you never once said it out in 6 months?
Take him out back and teach him a lesson.
All right. Maybe I'll let him teach the next lesson. The one I don't like teaching.
Oh,
No.
Okay.
I'd rather teach squeeze.
So, ladies and gentlemen, before we even start talking about derivatives of inverse trig functions, let's even remember what an inverse trig function is, okay? So, for instance, let's say I have this function f of x is, oh my goodness, what's going on today? F of x is equal to sine x. Come on. There you go. Let's remember, what is the inverse of sine? What do we call that?
Arc Sine or sine to the
Yeah. So if we're remembering this, it's actually for today and the rest of class, or the year I should say, we're going to call it Arc Sine. It's also sometimes you see it as sine with that -1 power. Okay, that means inverse for trig. So let's just pull some information that we've been doing the last couple days. So here, if I say f of pi over 6, well, what is sine of pi over 6? Not everyone at once.
1/2.
It's 1/2, okay? Malcolm and Manny, this is your warning. Okay? So therefore, if we're going backwards, if we're going into an inverse function, what switches?
The B and A value.
Yeah, the domain and range, right? So now our range becomes our domain, which becomes our range, okay? Does that make sense to us? You guys understand that? Very similarly, if I said f of pi over 3, f of pi over 3 is equal to what, of course? Radical 3 over 2. Therefore, if I really, but let's change it up. I'm not going to put radical 3 over 2. Let's say g is radical 2 over 2. This is kind of hard for us to remember, but what's radical 2 over 2? It's pi over 4. Okay. And then lastly, f of pi over 2 would be equal to what? What's the sine of pi over 2?
1.
It's 1. And then g of -1/2. So when is sine -1/2? That's correct. Okay. So just remember some of these properties of regular functions with inverse functions. Our domain and ranges are switching. Okay? So, you guys okay? Okay. So let's just go into derivatives. All right. So, so let's kind of start here. If I wanted to find the derivative of this, what does arc sine mean again?
Inverse sine.
Means inverse sine. Do you guys know how to change this around so it doesn't look so complicated?
Sine of y equals x.
So we can't do 1 over sine because that's technically not a power. In this case it means inverse, but good guess. So what we're going to do is we're going to perform the inverse of arc sine. What's the inverse of arc sine?
Sine.
It's sine. Okay? So what I'm going to do is I'm going to do sine of y is equal to sine of arc sine x. Do you guys see what I'm doing here? So if I'm doing the inverse to this is actually going to cancel. Okay. So now you have that sine of y is equal to x. And now you can go through and take a derivative using differential equations, okay? So what's the derivative of sine? So we're going to call this cosine y dy dx, or just how do I do it? I do dy dx. Okay. Equals, what's the derivative of x? 1. How do I get dy dx by itself? Okay. Okay. Now, it is strange, but it's about to get even weirder. Okay. So what I'm going to ask you guys to remember is to go back to our unit circle for sine and cosine, and let's remember what our stuff is, okay? So, I'm just going to draw a triangle. In a unit circle, what do you absolutely know has to be true? Pretend this is the origin, right? In a unit...
Has to be 360 degrees.
No. And in calculus, it's 2 pi.
You said
Unit. Unit.
It has to be
How many is unit?
1.
1.
Unit. Pi.
In a unit circle, the hypotenuse is always 1. Okay.
I don't know what we're talking about.
I don't know what we're talking about.
Now, so, what's the best way to explain this? Okay. And remember, we're dealing with an inverse function here. So what changes? What switches?
The y and the x.
The y and the x. Where would x be located here?
On the bottom.
On the bottom, right? And where would y be located? On the side. So I'm going to call this y and this x now. Okay. It does look weird because x refers to our angle, right? And y refers to our height. So the only unknown here is this side. However, in a unit circle, what are we always allowed to use? Pythagorean Theorem. Do you guys see what I'm doing here? So let's call this n, and we're going to solve for n. So I know that x squared plus n squared equals what? 1 squared, or just 1, right? If, Brendan, just let me teach. This is already hard enough. Just let me do it. Okay? So, n squared is equal to 1 minus x squared, right? And then to get n by itself, what are we going to do? Take a square root. Now you're all like, why did I do this? Here's why. Because now we can set up cosine of y using SOHCAHTOA. Okay? We can use, if we want to find cosine, cosine is equal to what?
Opposite over hypotenuse.
So
Adjacent over hypotenuse.
Okay, C-A. I know, I don't think Mr. Chong teaches SOHCAHTOA, so sorry. So adjacent would be this side right here. You see that? Over hypotenuse over 1. So in other words, dy dx is equal to 1 all over radical 1 minus x squared. And that's the derivative.
Wow.
Okay. Way complicated, huh?
Yeah.
Yeah.
Yeah, I don't like that.
I know. Okay. Ready for example 2?
Sure thing.
Okay. Here we go.
I feel like I'm going to have to draw a triangle.
So you will, but eventually I'm going to ask you guys to memorize it. Right now I'm just proving it. So y equals arctan 3x. Okay. So what are we going to do? We're going to multiply by tan. So tangent of y is just going to be equal to 3x. Okay. Let's remember. Now we're going to go through and take a derivative. What's derivative of tangent?
Negative, cosine over negative.
Secant x times tan x?
Oh, this is brutal. What's the derivative of tangent?
Secant squared.
Secant squared y in this case. But yes. And then we're going to put dy dx. Okay. Derivative of 3x. Just 3. If I want to go ahead and solve, what are you going to do? Yep. So dy dx is equal to 3 all over secant squared y. But again, I'm going to set up this triangle. Okay? So let's remember, y is the angle. So we're going to set up a triangle. Okay? Remember, how do I know y is the angle? Because that's what it's telling me right here. It's in the angle position. So y is the angle. Now, as crazy as this is not x in this case.
What the heck? Okay, what?
Here's y. Here's how come. Go back up here. Y was the angle.
Oh, so it's 3x.
It's 3x. Okay? So tangent of y is equal to 3x. The hypotenuse is still always 1 because we're dealing with units, a unit circle. I just lied to you.
It's 3.
You just lied to me, Miss. How could you?
I lied to you. Ignore that. This is why I hate this section.
What just happened to the time?
Okay. I just lied to you, and here's why. Here's why. Here's why.
Okay, now I need later.
Okay, hang on. Hang on. Let's back it up.
You're stressing me out.
I'm sorry. Okay, here's why. Guys, sine is equal to what? If we go to SOHCAHTOA, sine is equal to opposite over hypotenuse. So the sine of y was x. The opposite is x, the hypotenuse is 1. Opposite, hypotenuse. So far, so good. Okay, so let's bring it back. Here, tangent of y, tangent of my angle y is equal to opposite over adjacent. Okay, so why did I say the hypotenuse is not 1? Where did I make the mistake?
Oh, it's supposed to be
The bottom is supposed to be 1.
So we're using the ratio to get.
We're using the ratio to make our triangle, like you guys would have done in pre-calc. Okay? So I'm sorry, that's my fault. Now because we know this information, what can we create? We can create the hypotenuse. So h in this case, or h squared, is equal to 1 squared plus 3 squared. So what is h? How do you solve for h? How do you get it by itself? Take the radical, right? I'm using Pythagorean Theorem. So h is radical 1 plus 9x squared. Okay? I'm sorry. Forgive me. Okay? Shush it.
You're not dubious, so you're fine.
Okay?
Same.
So why is it what? What's 3x times 3x? Okay? All right. So ladies and gentlemen, we're not done here because I now have to think about what is secant of y. Well, secant is the reciprocal of secant is a reciprocal of who? 1 over cosine, right? So I have to understand secant of y is 1 over cosine of y. Now that I have this triangle, can we set up cosine?
Yes.
Yeah, cosine is adjacent over hypotenuse, or aka hypotenuse over adjacent. If I use that, because it's 1 over cosine of y. Did I do too much there?
Yeah.
So,
I blame your geometry teachers. Okay,
I 100%.
ready?
I 100% blame Mr. Beck.
Okay, guys.
same there.
So look, I have 1 over cosine, right? So what can I do with this fraction? I don't like a fraction within a fraction.
You're a freaking wizard, Miss.
I know. Okay? So that's what just happened. You guys okay? Okay. So now
Blew my mind.
Now that I understand what secant is, I'm going to write it in. So I have 3 all over secant says it's hypotenuse over adjacent. Okay. So I'm going to do hypotenuse, 1 plus 9x squared, all over adjacent, which is 1. I'm going to take that result, and what does it say to do with secant?
Square it.
It says to square it. Okay? Just stay with me. It's just algebra now.
Just follow me.
So it's 3 all over. I'm squaring a square root. What's going to happen? It's gone. And this is your answer. How did I do what? It's secant squared. So I found the secant of y, and then I squared it. Guys, these are actually really cool. I'm just not very good at teaching them, okay?
How are they so cool though?
And then how do we set? Do we just and then dy?
So this is, yeah, and this is your dy dx. Okay? Let's try one more, and then I'm going to have you guys do one on your own, okay?
That's what I'm saying, right? And this math is equivalent to bell tax. Funny. Because no one likes it.
It's annoying.
I didn't mean that. I know.
Have you guys talked to adults out here?
No, not terrible. That was mean.
Okay, but like sit by them every single day.
Nothing's happening.
You don't know what a bell target is?
The ones who ditch class and just hang out there?
No, they
Oh.
don't
They're much weirder than that.
They're just.
Sarah would be a bell target.
Oh no.
Anyway,
You said the point right.
moving on. Don't hurt people's feelings. That makes me sad. Now, okay?
Yeah.
So, ladies and gentlemen, what are we going to do here? First step, sine. Sine y equals what? Radical x. Okay, good. We're there. You understand that part? I'm happy. From here, we take a derivative. Derivative of sine is cosine y dy dx equals derivative of radical x.
1/2 x to negative 1/2.
Okay.
Oh.
Okay. Now, ladies and gentlemen, okay, let's go back. Let's look here because this is my original function, right? Let's set up a triangle. Now, let's make this a fraction since it's not one. So I have radical x over 1. What's my angle? No, hang on. What's my angle? Y. And sine is equivalent to opposite over hypotenuse. So that means this side right here will be radical x. This side will be 1. Okay, is that part clearer now?
Yes.
Okay, so what side do I need to find? Yeah, we can just call it n for right now, just to help me understand. So let's set up our Pythagorean theorem. Radical x squared plus n squared equals 1 squared. Okay. I'm squaring a square root, so that just becomes x plus n squared equals 1. So therefore I get that n squared is equal to 1 minus x. Therefore n equals, you got it. Okay. You guys okay? Now let's go through everything I need to do. I have dy dx. What do I need to do? Isolate it by dividing. All right. I'm going to do this, and then I'm going to clean it up. And if you guys can't follow along, I hope you can, because I'm going to be upset. Okay. Everybody understands negative 1/2 x. Why do I have negative? No, positive.
I was like, no, I don't understand.
Okay, sorry. Positive 1/2 is because I saw this negative. X to the negative 1/2 cosine y. Are we cool?
Mm-hmm.
Okay, I'm going to clean it up. Follow along.
I knew it.
Are you there?
I'm with it.
Okay, cool. Cosine of y. How am I going to find that?
Triangle.
Go back to your triangle. Cosine is equal to
Adjacent over hypotenuse.
adjacent over hypotenuse. If you guys need to do like a little thinking bubble, like cosine of y is adjacent over hypotenuse, therefore I have radical 1 minus x all over 1, okay? Just to help you understand that. So, dy dx in this case is equal to 1 all over 2 radical x times what?
Radical 1 minus x.
And this is your answer.
Distribute that radical.
We can, but no, you can't actually.
Okay.
No, these are terms. If it was a product, you could. Those are terms, therefore it's one complete factor. Okay. How do you guys feel? I feel like that last example was a little bit more solid.
Yeah.
Wimps. All right, I'll do the fourth one with you because I do feel bad. I do feel bad. Brendan, you always work ahead anyway.
My eyes
That's true.
Did you do your essay?
I feel really proud of this essay.
I can't really, that's something, might be a contract.
No business essay to you guys.
On time?
On time.
Is it good?
He read the book.
Yeah, I'm going to do this one
Did the
with
audio
you.
book, first of all. I was talking to him about it, he's like, yeah, so I read it, and I was like, really, you read it? He's like, well, I listened to it.
Okay,
Multiply by 10.
so hang on a hot minute. We can't multiply by tan because there's an x squared.
Divide by a square.
You can't. You can't.
What do you mean you can't?
Woo!
This is product rule.
Yeah, you can't. It is product rule.
Oh, no.
Wait, what were we doing before?
Just regular?
Not product rule.
Okay. So guys, this is product rule. So we're not worried about taking the derivative of x squared. What are we worried about? We're worried about taking the derivative of arctan, right? Okay. So it's not that we're going to separate them, but we are going to have a separate think bubble for arctan. Think bubble, yes. Okay, so I'm gonna even think it up over here.
Ooh, there's the bubble. Oh, blay.
I know I'm going to have a hard time taking derivative of arctan. So what I'm going to do is I'm just going to put this off to the side. Okay, can you guys see how that's like my separate one right there? We're good? Okay.
It's like you suck.
Kind of. So, y prime in this case. We're not even worried. What's the derivative of x squared? 2x times arctangent, right? Now, plus, what's the derivative of arctan x? Well, that's what we have to be worried about. So we're going to go over here. Now you're totally allowed to do what? Multiply by tangent. So tangent of y equals x. X over 1, just because I know I'm going to need a ratio. If you guys even want to set up your triangle right away, that's not a bad idea. What's your angle? Your angle is y. Tangent is equivalent to TOA.
Opposite over adjacent.
Opposite over adjacent. Okay. How would I find my hypotenuse?
Pythagorean theorem.
Pythagorean theorem. Just because you guys can sit there and do it, but I know it's 1 plus x squared. Square root of that.
And you have to square for the
Okay. So I just set up my triangle. You guys okay?
Yes.
All right. Now,
I'm doing the
we haven't actually done any derivatives yet. Take a derivative. What's the derivative of tangent? So secant squared y dy dx. What's the derivative of x? 1. So I know that dy dx is equal to 1 over secant squared y. What is secant squared? Secant is 1 over cosine. So that means secant is 1 over cos. Cosine is adjacent over hypotenuse, so therefore hypotenuse over adjacent. So dy dx is equal to 1 over hypotenuse over adjacent, which is actually super nice, all over 1. And because it says secant squared, I'm going to square that result. So I get 1 all over 1 plus x squared.
Wow.
So now what I've done is I found the derivative of arctan.
Oh, so then we just.
So 1 all over 1 plus x squared times x squared. Now some of you like to do this and I want to slap your hands. Do not cancel out those x squareds. This x squared depends on that 1. This is a factor. Okay? But guys, that's your answer.
That's it?
That's it.
Wait, what happened?
You're done. You've done the product rule. We took the derivative of the first function times the second.
Just leave it like that?
Yeah, we took the derivative of the second function times the first.
I was thinking, could you simplify it more?
You could if you wanted to multiply this by 1 plus x squared, but I wouldn't. I would leave it as this. This is already complicated enough. All right. So, I'm done.
Oh, wow.